Okay, so this is today's daily problem, which is delete columns to make the sorted. So you have been given an array of n strings. So basically, it's a vector of strings, you can say, which can be represented as grid also if you write strings in line by line like A, B, C, B, C, C, A, E. Now you have to, consider the columns that this grid is forming. The columns are A, B, C, B, C, A, C, E, E. So among these three columns, you have to delete those columns which are not sorted lexicographically. If you see this BCA, the second column is not lexicographically sorted because lexicographical order is ABC, and that's why you have to return one in this case. And in this case also, like you can see, if you create a grid, CDG is sorted, BAH is not sorted, AFI I think is sorted, 0 and 2 are sorted, 1 is not sorted, you have to return 1. So you have to count how many number of columns which are unsorted. So for this I will just iterate over the given string matrix or string vector or this grid, whatever you can say that. But then the basic thing is you have to traverse it by column. So I'll create my column in this vector x and push back all the elements of the particular column, and then I will check whether my vector z is basically whether your vector x is sorted or not. If it is sorted, that's okay. If it's not sorted, I will do counter plus plus. At last I will return the value of counter, which will tell me how many columns were unsorted, right? So that's about it. Let's move to this GFG problem of the day. Minimize the number of students to be removed. Okay, so you have to basically given some students in form of array, and basically array elements is the height of the student, and you want to basically assemble the students in order that increasing heights. So some student which is height less than or equal to if standing in the front of him, he can share that cannot see the assembly, right? If basically, yeah, basically if nine children of height 9 is standing in front of children of height 1, he cannot see the assembly, right? So what you can do, you can just remove this 9 from here. So you have to find the minimum elements, basically minimum number students that you have to remove, minimal elements that you have to remove, so that the maximum possible number of students can see the assembly. So this is nothing but in this case, like it would be 1 2 3 and 5, 9 and 1 you have to remove. So how we'll do this, we'll do this by just using the dp normal and then dp of size n, you can say, consider it as 1, and then for int I equal to 0, and maybe like we can use it just as vector n and v and without anything. If your what if your h, or you can say if your v is empty, or your v dot back is less than this h of I, then you can say that okay, I'm gonna say you can just push it into that, push back h of I, and after that what you can do, key else that it's not a correct order, you have to find out the breaking point in order I is equal to what h dot lower bound doesn't make sense, but lower bound of h makes h dot begin dot end, and you have to find for element which is h of I think, yeah, and it's not h, that's v. Now you have to say whether if your I is equal to your h dot not h but v dot n, then you have to say okay, you can't really do something, so you just push v dot push back or h of I, else you have to replace. So basically you can do key star of I is equal to this h of I, and at last you will return the length v dot size. These are the basically total number of elements which can be there in a line. So let's see, yeah, maximum number of elements. Okay, so basically you have to return n minus v dot size, and you have to write over here as n. So if the element is good, you'll just push back, else you have to find the lower bound for that element. uh photo. Okay, so for this matter you have to say it and it over here as well. Yeah, let's try to sum this up. Okay, pretty good. Yeah, so that's accepted. So that was all about this problem. You have to calculate it, how it is the minimum number of students that can be arranged in line. So basically, you first of all you'll calculate. Oh, you have to delete. Basically, you have to calculate how many numbers you have to delete. So you'll calculate how many numbers you have to arrange in line. Then how many numbers were total. So take the difference from them. That would be your answer. And that's about it. Okay, guys. Bye.